Hi,
Okay,
thank
good.
you to everybody. So thank you, Andrei. So it was a very interesting panel and very interesting discussion. So I hope that we can go ahead in the same line with the first technical session of this conference today. So this session is about tools and methodologies, and we are going to have 6 papers that have been selected for this session. So this session will last for 1 hour and a half till the, let's say, lunch break. So we do not have a real place for lunch, but each of us can just have an hour for food. So the first, I would like to start immediately. So the session is with the paper's length of 15 minutes, including questions. So I ask all the speakers to be quite in time. In any case, I will just warn you when the time is over. So please let 5 minutes at the end for the questions. So please try to keep 10 minutes plus 5 for the question. So I would like to introduce the first paper, that is Energy Efficient Software Development Process Evaluation for macOS devices. And the presenters will be Stokista. So please start. So thank you.
Afternoon. My name is Stokista Ergasheva. I'm junior researcher from Innopolis University. Today, I'm glad to see you all, and let me share my screen. Do you see the screen? I think yes. Yeah. So let me start. So today, I will present you our tool for energy efficiency of the software development processes, particularly for macOS devices. Today, I will try to give general information about the measurement of the software development process, why to measure, what to measure to make the process more energy efficient, and tell about our framework that we developed together with our team members. We know that the software, including its soft artifacts produced with computer, is invisible and complex. And the difficulty in visualizing it makes it difficult to reason, to communicate about it. And also, it is hard to understand the status of the work, the progress of the work. And so in order to make it more reasonable and easy to understand, we conduct software measurement processes. And the software measurement process, we know that it's ongoing process and the process of identifying, analyzing, and collecting the data about the software development process itself, its results, in order to understand and control the process and its outcomes. And furthermore, it provides us important information to improve our process and of course, the product itself. If we look to the history of software metrics collection methods, it can be divided into two methods, into 2 generations. The first generation is called invasive method. It is known as well as personal software processes, a self-improvement process that helps developers to control, manage, and improve the way they work. And it also requires the direct involvement of the participants in the data collection process. The users of this method should create the print the forms, and they will log their effort size and the defect information on these forms. One obvious downside of this invasive method is that the high overcost it entails, and the developers should often switch between the tasks. between the developer task and the metric collection tasks. It is, of course, imposes a high cognitive burden to the developers, while non-invasive measurement methods do not require manual intervention of the developers during this metrics collection process. If we apply non-invasive measurement method, it means that we value automatic measurement more than the precision. The concept of non-invasive measurement drives the development of the entire framework. So the system we are introducing today is called Inometrics. It is developed based on the non-invasive data collection and monitoring of the software development process, its energy consumption, and its efficiency, and of course the developer's productivity. The main concentration in the scope of non-invasive software development process analysis in this approach is that the energy consumption tracking of applications will be tracked during the software development process life cycle, during the whole day. Here is, you see the main physical view of the system architecture, where we have main components like user devices. It will be tracked by the data collection components. Mainly, these are the collectors for different types of operating systems. Particularly, we'll talk about macOS collector today. They are only used for data collection, storage, and transmission. And the next component, we see here, the managers. It will present the user with the manager role for each of the project. They will have access to the dashboard that will make available to them the information about the data collected from their work team. And Inometrics dashboard is a web system focused on providing graphically the information obtained from the analysis of the data collected. This data is to be presented for managers for mainly decision-making processes. And Inometrics database component, it also, the data captured by the different data collection components will be stored in this central repository, which will later be transformed by the analysis service. So if we talk about energy metrics, we know that application energy consumption depends on a variety of system resources like processor, the device uses, memory architecture, displays, and so on. And it also depends on the various conditions like the signal strength used for data transfer, user settings like screen brightness levels, and many more user and system settings. As we researched in the energy consumption of software process area, we derived for ourselves two main energy metrics like software energy consumption and unit energy consumption. Considering our profiling method and the tools available for us, the ability to attribute the energy consumption was possible only at the process level in coarse granularity. However, the hardware resource usage can fill the gap when it comes to accurately relating energy consumption to individual software elements, hence enabling the computation of the unit energy consumption. The profiling, the performance requires the basic understanding of hardware components that has to be monitored through performance counters. And while interpreting performance data for further analysis, the context information has to be taken into account, such as hardware-specific details. To evaluate the unit energy consumption, the following hardware resources should be monitored, like processor, hard disk, memory, network, and so on. attributing some weights to elements of the unit energy consumption or by some reliable assumption, considering that the power model to be linear in nature for each individual component. The software and energy consumption metric can be computed in this way. And in order to obtain energy-related data in macOS devices, we explored some of the APIs that macOS provides. The first thing and the most obvious tool was to use Activity Monitor, the application that comes built in every macOS system. And using the findings from the articles we researched, we decided to use some of the most impacting metrics for the software development process efficiency. All of these metrics were obtained using the macOS command line interface. And today, particularly, we'll look closer to the macOS data collector development. It is one of the data collectors for collecting, storing, and transferring the data from the user's devices. It includes two separate applications using a service-oriented approach. Inometrics collector is a daemon process. It runs in the background, and the only interaction the user has with this application is that the collector sits in the background and collects the data. Inometrics collector displays the user information, as you can see here on the left picture. User information like name of the user, API address, system versions, specifications, and so on, as well as the currently open application. And the collector also shows the idle time tab, the picture on the right. It shows the total idle time and the top 3 applications that have been idle for the longest. Here, the user can change the time interval to send the data to the central repository from the local repository, or to stop the process of the data collection, or they can just quit the app. After collecting the metrics, the system saves the current session with detailed information with this set of attributes. Then it saves the data to a local database, allowing the Inometrics transfer application to send the data to the server. So Inometrics transfer is a separate application. However, it is not the daemon. It is a GUI application which allows the users to see all the metrics that have been collected in addition to the functionality of sending such data to the backend. It also consists of 2 main areas, as you can see here, the left bar and the process metric lists on the right. We have a feature to filter processes based on the keywords or applications, or just by time intervals by date. The data is automatically and periodically being sent to the developers, to the server, so that the developers can work without any distractions during the work. We also implemented auto update functionality as far as desktop applications in general suffer from inability to update frequently. So for today, that's what I wanted to share with you. If you have some questions, I'm ready to answer. Thank you.
So thanks a lot for your nice presentation. So questions. So maybe I can start with me. So, okay, we have another question in the chat. How we can use received metrics, maybe some recommendation to reduce the energy consumption?
So, so particularly if we talk about our system, we use the metrics. We collect the metrics and save them to our database, and then here will be some analytical methods. We will use neural network algorithms to sort them, to categorize them into different categories. Like we can categorize them as development, entertainment, or management. And then we will show in which category we have the most energy consumption. And in terms of this information, the managers or the directors of the companies can get some insights about this process and to decide themselves how to minimize this energy consumption in this particular process or category.
Okay, thank you. Other questions? So I can ask one question about that. So do you have any information about how precise is the data that you are collecting?
How precise? So for now, we are collecting the process names with different kinds of applications that the developer uses during the whole day. And of course, it's time, start time and end time of the process, and the battery level, for example. The battery level in the beginning and at the end of this process. In terms of this kinds of detailed data, we can compute the metrics that I presented. Energy consumption, software energy consumption, and unit energy consumption.
Okay, so perfect. I think that we are perfectly on time. So thanks a lot for your presentation. And now I would like to introduce our second speaker for the paper titled An Open Source Environment for an Agile Development Model. Marcello is going to present it.
Okay, hello everybody. My name is Marcello Missiroli. I work in a research team at the University of Bologna with several other people. Today I'm going to present you our tool which is used for developing open source and software within an agile framework. I try to share the screen. Hope everything goes fine. Okay, so excuse me, it's the first time I'm using Zoom. Hope everything is fine. Okay. Okay, this is the agenda for today. I will show the first requirement of a open source software development, our environment for agile development. Then a short description of the iAgile method. Then we'll show the CAS system, and we'll just shortly describe future work on this field. Okay, so whenever we tackle agile development, in general, we are confronted with several of existing tools. You will probably have seen most of them, and probably used a few of them. In the specific case we are considering, which is high security and possibly military environment, not all these tools are equally usable. And in our case, we developed a system, a development system called the iAgile, which is a variant of Scrum, basically derives from Scrum, which is tailored for critical system, and specifically for the military domain. As you can see, there are several. We mapped the agile principles, or the XP principles, to tailored for the specific military and high security method. You can have a look how they are mapped. But the main thing is probably that we wanted to include no commercial tools and no online tools. So the main reason is obvious, which is high security cannot be stored in servers that are not under one's control. And even data cannot freely flow outside and inside the organization. So what we allowed is only open source software, which can be deployed in a private cloud internal, or even run locally. So given this constraint, we developed this system, which we named the Composable Agile System, which is an environment suitable for multiple teams, and is in practice a composition of existing tools bound with some software devised by our own. So, for example, as an IDE, one can either use Eclipse, IntelliJ, or Atom. As a collaboration tool, we chose Taiga. As a communication tool, Mattermost. As a versioning, GitLab. For quality control, SonarQube. For issue tracking, Bugzilla. For pair programming, Saros. And for data collection, we developed a specific login tied to the database. Being an agile system, we also developed it as an agile system. So we devised several user stories that describe the evolution and the development of the system. And for each, we found the specific tool, and we integrated it into the system. As you see, there are the classic agile roles, which are derived from Scrum, plus the AD, which is the administration, that of course in a high security system plays an important role. So even we can also see that there are several use cases which are mapped on one or more user story.
Sorry, there is a question.
Yes.
Why did you select these particular systems, Taiga, Bugzilla, and
okay, I'll come to that. I'll see the various components one by one in a few moments. So I'll come to that. So the basic architecture is this, which is not particularly complicated, is a server in which every system or subcomponent is hosted in a Docker container, and at the end user can use basically any operating system he wants. And some, as you can see, some components, especially the IDE and some plugins are run. So why we chose the specific tools? We are, of course, selected, examined a few of them, and given these constraints, sometimes the choice was obliged. We chose Taiga, which is an open source project management tool, because it is open source, it is new, it is relatively easy to install, and it is relatively easy to modify. So this was our first motivation. In the case of SonarQube, essentially there were no many other alternatives. There are possibly a collection of text tools, but no single tool offers the wide range of matrix that SonarQube provides, which is also open source and locally installable. The instant messaging tool was a little more complicated. We found Mattermost at the moment as the best choice, and which is also an open source tool. And we favored Mattermost with respect with old style chats, for example, Gabber, similar, because it was more in line with commercial tools and offer the same, more or less the same functionalities. The data logger is something that allows it's a small services which is run locally. It is integrated in the plugin of the client, and it records all keystrokes input by the client in the device. We can then later, by the developer, we can then use this data to analyze and generate some data, administrative data for and evaluate the productivity of the team, for example, and many other things. What is the status and the evaluation of our system? We are using this for developing our internal project, especially in education, which is at the University of Bologna mainly. And we are still, the project is still evolving. We have not, for example, evaluated the system with multiple teams. And we are considering adding other tools, for example, for testing continuous integration. They are not still part of the system, but probably be in the next release of the system. Okay, there are, of course, some problems we are considering, and one is probably that of using different open source licenses. As you can see, there are some are GPL, LGPL, Apache, and packaging everything under a synchronizer is difficult. You can also add the European public license we have heard of today. And this might be problematic, but we are looking into that. The second thing is probably more practical in nature. All of these tools come from active communities that frequently update tools. They might even introduce radical changes. This might break the general functioning of the tool, and this requires some to be looked into specifically. In addition, some tools are young, some are problematic, and maybe some will die because the developers give up the project. So we are continually looking for alternatives. So the next version might include different tools. That's one. So this is in general the status of our project, and I'm here to for other questions if there are. I haven't seen them. Okay.
Okay, so thank you, Marcello. So are there any additional questions? Yes. What is the AD role?
So I don't know if Paolo wants to speak on the specific case, which is field. In any way, the AD stands for the administration, and as you can see in a high security military environment, there is a degree of control which is required that is normally not necessary in standard open source projects. So the administration has the possibility to check and control almost every aspect of the development, checking how it proceeds and possibly giving advice when needed. So the thing is that it is required a central dashboard or a control room from where the administration can have a look how the development process is going on.
Okay, perfect. Are there any other questions? I have a question. How long did it take for this kind of study?
So generally it's here a year and a half generally, though the study is a continuation of a process which started long ago, and it as the project ended, this has evolved as an independent project that provides the export the environment for any other project. So first it was developed internally for this military project, and then it was expanded. So I'd say as an independent work is about a year and a half.
Okay, perfect. Thanks a lot, Marcello. So thank you for your very interesting presentation. So we still have one question more. So please, how the high security worth IAGI is guaranteed with the use of all these open source components? How the security is guaranteed?
Okay, so this is a tricky question, and guaranteed is possibly a difficult word for this. In general, what we think, and generally everybody can agree on that, is that if you can use open source software, you are relatively sure that what you do and what the system does is controllable, because you can inspect software and see what it does. And as the software is hosted on your system, and the system is at least as secure as your general environment is. So instead, if you run software, closed source software, or which is where data is hosted in some remote server, you cannot be sure of that. So this is not a guarantee, a 100% guarantee, but it's probably the best you can have.
Okay, so thank you, Marcello, for your talk. Thank you for the questions. So we can go ahead with our next presentation. that is titled Combining Two Modeling Approaches, GQM and Chaos, in an open source project. So the presenter will be Nursultan. So can you start?
Hello, everyone. Can you hear me?
Yes, very well.
Yes. That's great. So let me share my screen and I will start the presentation. You can see my screen?
Yes, it's working.
Okay, great. The topic that we will be talking about today is how we can combine two modeling approaches, GQM, goal question metric, and chaos, keep all objectives satisfied. These are two modeling approaches that can be applied in requirements engineering and how they can work out together in a context of an open source project. So first of all, let's have a quick look on what GQM and chaos is and see some toy examples for them. So GQM is in its essence is a way to, whenever you have a goal, organization or a project goal, how can you make it measurable? And you make it measurable through asking appropriate questions that make this goal more, I would say, concrete. And the approach has three levels: conceptual level, operational level, and quantitative level. And they exactly correspond with them. On the conceptual level, you have a goal, then you ask questions, and it allows you to arrive at metrics. So let's have a look at an example. For example, here we have a goal that improves the usability of the ticket booking feature from the point of view of a person booking a ticket, end user. So the toy example here is that we have some system that allows users to book their tickets for airplane or train. And when we formulate a goal in GQM, normally we try to formulate it in terms of 4 criteria. We want to say the purpose, the quality issue, object, and the viewpoint. So the purpose here is that we want to improve. Improve what? Usability. And the object is the ticket booking feature. And the viewpoint is from the end user's point of view. So as you can see, it's quite a comprehensive look on the goal. And the question is, since here we are trying to improve usability, it's a vague goal without actually providing how do we measure it. And one question we can ask is, how long does it take a user to complete the booking? And to answer the question, we can have several metrics. For example, we can have average task time that it takes a user to complete the booking. We can see at the standard deviation from the average and percentage of cases exceeding the average maximum limit. So these metrics can provide us the answer for this question. We can also ask other questions like, what are the completion rates of the feature and how satisfied are the users with the feature? And the metrics can be different. They can be objective or subjective. They can be measured or and direct and indirect. So GQM is quite flexible, but the main idea, as you can see, is that we start with a goal and then we find a way to measure it. And this is being software engineers, obviously, we want to measure everything. And the other approach that we're talking about is chaos, or keep all objectives satisfied. And this is a goal modeling approach. So in the essence, it's like a mind map, which gives you a lot of formal notation or a lot of ways to show the relation between your goals. So you start with some high-level goal, and then you proceed by breaking it into lower level goals, more concrete objectives, right? Let's have a look at an example. So if our goal for a system is to ensure data confidentiality for our users, we can know that, okay, what can be an abstraction, an obstacle to achieving this goal? And the obstacle is that the data can be exposed due to maybe 2 reasons, either user mistake or intrusion attack. And in this case, we can propose countermeasures against these obstacles. And on the user mistake, we want to educate our users on the basics of security. And intrusion attack, we want to avoid unauthorized access. And then when we have these more concrete goals, we can moreover attach them to agents responsible for fulfilling this goal. So in this case, educating users, it's responsibility of a security officer. a person agent, and for avoiding unauthorized access is the authentication module. So this way we can identify what are the agents, what are the relations between goals. And actually Chaos itself provides a huge amount of, like, it's a very rich notation, and I would say even heavy. And it allows you to show to identify conflicts between your goals. And you can even provide more detailed view where you define your goal, you give it category, criticality, even formal specifications. So as you can see, it's, and probably the main benefit of it is that it provides you a visualizing of your goals. So it's diagram, and it enjoys the benefits of maybe increased readability for people. Instead of just reading the text, they can have a look and have a good overview of the goals for the project. Now, if we want to combine the two approaches, what could be the benefits? First of all, with Chaos, we can break business goals into specific objectives and assign them to agents. Through GQM, we can get them measurable, our goals measurable. And also Chaos provides this diagrammatic notation, so maybe we can like extend this diagrammatic notation and include GQM into it, and overall see how goals, agents, metrics, how all of them, what is the interplay between them. So here we try to apply this approach to an open source project. So the open source project, it's a Kin app, and it's an application that helps users to keep in touch with their family, friends, and relatives while being away. I think this maybe, especially at the time of self-isolation, it makes sense. And the high-level goals that we have is to maximize keeping in touch for our users. And after doing some research, we found out that most people who want to keep in touch with their important people in their life and don't do it either for forgetfulness, being busy, having other priorities. So that's the obstacle preventing them. How can we resolve it? Two resolutions that we can suggest is we can list and prioritize people to keep in touch with, to introduce some like order and organization, and then we can send some sort of reminders. We can remind the users to keep in touch. So these are like two middle level goals. Then we take these two middle level goals and further break them down, that, okay, if we want to list and prioritize people to keep in touch with, we can add contacts with regularity. So we add people and how often do we want to contact them. And here we provide them the priority of the goal, it's high. We can display the list to the user, and again, and for this we will have two modules. One of them that lists all the people added, and another one that allows you to add new people. We also want to remind to keep in touch. So in this case, the more concrete objective is to send push notifications, which one way to remind. And for this we will need in our system some remote notification module. So if we now talk about GQM part, how can we use GQM to make our goals measurable? And in this case, probably it would make sense to make our high-level and mid-level goals, which are not very concrete, measurable, and try to see how we can measure their achievement. So here we introduce a new diagrammatic notation. These are our metrics. So for example, for maximize keeping in touch, we want to measure streaks of and streak is an unbroken sequence of people that, for example, if you decided to keep in touch with your uncle, for example, for every week, how many weeks in a row did you do it? And we can see what is the average streak for people, what is the longest streak, and also we can see that, okay, how usable is our listing and prioritization feature by seeing, okay, what is the percentage of successfully completed contact additions, and what is the number of contacts added, and also we can see the effectiveness of our push notifications to measure them and maybe try to improve. So altogether, if we have a altogether look, we will see that in the middle we have the high-level goal. Then if we go down, we break them down into specific goals, and on the top we can provide the metrics, and this is kind of the interrelation between the project objectives and the metrics and the agents. And one more thing that I wanted to add is that while producing metrics, since we want to measure average strake counts, the strakes, the unbroken sequences, it means it can result for us in new functionality, because now it means that we have to have this strake functionality. So we introduce a new goal saying track strakes, and for that we will need some data persistence module, because we will need to know, okay, what is the historic data for a certain user. And you can go further. You can see, okay, if we are keeping some historic data and all of this, we can talk about data sensitivity. So as you can see, the approach allows you not only to arrive at something fixed, but build upon it. And like the metrics will produce new functional requirements, and also you can also provide you a way to measure some maybe non-functional requirements, as we can see here with usability. So this is the approach. And if we try to analyze how successful is it in the context of this open source project, we arrived like at several conclusions. So there are advantages and disadvantages as always. So probably the greatest advantage is that it's if at the beginning of the project, it allows you to formulate what are your goals, what you want to achieve, and it provides increased readability and transparency of requirements. So maybe this is a benefit that an open source community can enjoy. So everybody can see where the project is going and like what are the objectives of the project. And similar to it is the ability to trace the origin and intent of project objectives. So to see the interrelation and how these big goals translate into concrete functionality. So these are the advantages. The main disadvantage is, as you can see, and as I already mentioned, is that the approach is quite heavy. So maintaining it is like problematic, and maybe it can be a critical issue in the context of an open source project, because open source project, the community maybe would want to keep the documentation to minimum and like to be able to maintain it easily. So as always, it's a trade-off between expressiveness and ease of use. So maybe instead of chaos, which is the main source of complexity, a more lightweight model and approach could be used depending on your project context. Yeah, and that's I think pretty much it. That's the presentation. Thank you. If you have any questions, please let me know.
So thanks a lot. I think we have a question here in the chat. What is the principal difference of presented approach with the GQM Plus model, which also has goals at different levels, from business and measurement goals, and the ordinal GQM at the bottom level?
Mm-hmm. I think the main difference is the expressiveness of chaos and the advantage that gives you. Since with chaos you can provide the interrelation between goals, but also you can show the agents, you can provide formal specifications. So I think the main difference is that we actually enjoy the benefits of chaos. But in principle, it's maybe the approach is similar. The question is again, I think the expressiveness of your tool. So that's my opinion on it.
Okay, thank you. We have another question. How you can control the depth of the sub-goals and how many levels should be?
Oh, that's a good question. I think it depends on how specific you want to be. And I think one consideration, obviously, you don't want your goal model to be too huge. So sometimes you might even skip some steps in between and just keep them implicit. The trade-off here is that you want your goals at the bottom to be concrete. I think this is very important. But also, since if we're talking about requirement stage, when it's a question, when does specification start? When do we provide exact solutions on what the programmers have to, or the system designers? So I think that's a question of how deep you want to go and how much you want to say what exactly you want to see as the end product. That's the main, I think that's the main question to answer. But overall, the general recommendations from my experience is to keep it as concise as possible. So don't make the goal model too big, because then it's not readable anymore. And another thing, try to arrive at something concrete at the bottom, such that you can assign it to specific agents. But maybe it's better to leave the options open in terms of, for example, here, I mean, I provided push notifications. Maybe this is too much of a direction what exactly has to be done. You know, maybe if it's requirement stage, you don't want to be saying exactly how to do it, but rather saying what needs to be done, if it makes sense.
Okay, so thanks a lot. So it was a very interesting presentation. So I kindly ask Gerta to start the next presentation, that is titled An Empirical Analysis of the Maintainability Evolution of Open Source Systems.
Hello everyone, I hope you can hear me.
Yes.
Well, I'm trying to share my screen. Just a moment. Can you see my screen?
Yes, perfectly. So please.
Okay. I'm Gerta. I'm studying at Innopolis University. And first of all, I want to thank you, the university, for holding such inspiring event. The paper is about an empirical analysis of the maintainability evolution of open systems. Okay, I'm trying to zoom in, maybe it's better. Software maintainability. Actually, I'm pretty sure all of you know what is software maintainability, and also what it means, which is the ease or difficulty with which a software system can be modified, and also the key software quality known. Here in red, you can see the two formulas. The first one is MI without comments, while the second one is the one with comments, so that has been used also in this paper. Why such choice? Actually, I have to admit that it was like a personal choice because of the personal style of coding. I like to code clearly and to specify comments in order for me and for other people later on to understand. And it was pretty much a good decision, because I heard also the previous presentation, it was discussed this thing of open source project lacking a bit of documentation. It was previously stated with some issues about that. So I think we were on the right way of choosing MI with comments. Well, having said that, why maintainability? We saw the definition and the theoretical part, but it's essential to know also the practical part. Why maintainability is a question that everyone has to ask. And I think the answer is pretty clear, that at the very end of the day, I think it's because it's strongly related to business, as everything else in life is related to business. Everything is related to business, but to me, when I hear about maintainability, despite the classical definition, I would identify it as the sign of the rainy day. Why? Always relating it with business, because business to me, it's two things. It's cost and quality. And using maintainability for cost, we can easily reduce the cost in very early stages of producing our product, our software. And the second one, which is the quality. Okay, we are a big enterprise, we are a big company, we are trying to sell and produce a very big product, but we are trying to put all the best quality. But why not to make a product which is sustainable and maintainable, and we are trying to impress our customer at the very end of the day. Having said that, let's start with our project, our investigation. The first step is the general one, is the analysis of software maintainability change, relying on general information outside source code. For this purpose, we used 5 open sources, which are JEdit, JWebUnit, JXLS, JDTS, and Helix. But for this presentation, we are giving results only for the JEdit project. Basically, we collected metrics we are going to talk later on for this project through JHawk tool, which is a tool that collects metrics for Java programs. And then we analyzed them with Jupyter Notebook using statistical packages using Python language program. In the step 2, as we mentioned, we collected the metrics which are part of the MI formula. As you can see, is the average hosted volume, psychometric complexity, which basically stands for the complexity of our code, which we are going to refer later on as CC, lines of code, LOC, which is the size of our code, maintainability index, MI, and MI less than 65 is difficult to maintain. Between 65 and 85, we can say that it's pretty maintainable. More than 85, it's good maintainability. This is the definition from literature review that we are using in our project. Always and always relating to literature review, relating to what other people and researchers have worked on their previous studies. Well, let's say 2 words about our results. As you can see, we had the MI evolution on the left part in here. And well, you can see that the trend initially in the earlier versions of JEdit is pretty constant. It gets lowering in the middle, it's pretty flexible, until on later version it starts increasing, which is interestingly enough compared to the size, to the LOC metrics, because we can see that they have like a similar approach, and it's relevant to highlight here the fact that LOC and MI on the later and latest version of this project are getting increased and are following the same trend. Well, let's see the next metric, which is complexity, psychometric complexity, as we are referring as CC. Here is pretty different. We see that it's much more flexible, and always we are kind of interested on the latest release of the project being studied here, and we can see that the trend is pretty different. On the latest versions, CC tends to get lower when MI tends to get higher. Having said that, we went further with our investigation. We did the testing correlation because we want to highlight here the fact that, okay, we are presenting the MI formula. There are certain metrics we are taking into consideration that obviously are part of this formula, and obviously exists correlation between the components, the metrics, CC, LOC, toward MI, but we want to kind of emphasize the strength of this relation. And for this purpose, we are testing the correlation with spearman rank correlation. Why? Because it's the test that doesn't need any assumption on the distribution of data. Well, we reached so far our results. Here is the final view. You can see for the 5 of them. Well, as you can see here, there is the results in red are the pretty significant one, as you can see from the p-value. It's interesting to see that between size metric and MI, it comes, as I stated earlier, and here we can see in terms of numbers, in terms of the test of the correlation, that exists like a positive correlation, especially respectively for GTDS and JXLS projects, while kindly quite the opposite of it for the complexity metrics with MI, which is a negative relationship. Instead, for sound helix, it's kind of interesting to see that almost exists non-significant relationship. Well, we reached this conclusion going back to our data. We saw that for sound helix, we did not have much of log versions, so we kind of given like the blame of this factor for such reasons. So we didn't have enough versions for these projects in order to have a significant results or to kind of say something at the very end. So we justify the result with this this purpose. Conclusion, what we did a preliminary analysis of the maintainability with these 5 popular open source projects. And I again highlight here that we wanted to see how strongly was the component, the metrics correlated with our maintainability metrics of these projects. Thank you. If you have any questions.
So thank you, Gerda, for presenting this nice study. So are there any questions? So maybe I can start. So basically, can you a little bit tell something about the fact that the maintainability index is composed by, for instance, a line of code and complexity? Why you are studying this aspect? Of course, there is correlation, is obvious.
Because when, well, I say that the main question or the most appropriate here will be like, why maintainability? I explain maintainability like the real reasons, but why these exact components? Because I specified from the literature review, these are the components that are part of the formula. So we decided to take each and every one for this specific projects. The question here and the very important aspect is that we wanted to build a unified database, which means that we are collecting certain data of certain projects in order to not have missing data, and these metrics to be collected for each project. So we choose only CC and size metric only because we had enough data for all these 5 projects, which are built, let's say, in Java language, and we excluded, for instance, housed metrics, as we see from the presentation. Okay. I don't know if I answered to your question, but basically this was the idea. We excluded some metrics because we had not enough data, and we concluded only like CC and LOC.
Okay, so thank you. We have another question. Is a maintainability index influenced by the implementation language?
That's an interesting question, actually. I wondered myself when I started these projects also with other team members. And I would say from what we have read and from literature review, I would say yes, but mostly the component that have the biggest weight on MI are the metrics that are being collected, and the metrics do not differ so much from the software language that is being used. As I mentioned earlier, we wanted to have a strong and unified and solid database, and for this purpose we use Java programming languages, but for other reasons or future work, we may use another software language. So the aim is the metrics collected that you are using and not the programming language.
So I think it's worth further investigation in the future. Okay,
Yeah,
so let's thank Gerta for the presentation. So thank you. So, and let's introduce the next one. So the paper is titled How the Cathedral Embraced the Bazaar and How the Bazaar Became a Cathedral. So Valentina is going to give this presentation. So please, Valentina.
My screen. Can you see my screen now? Sorry?
Not yet.
I don't know what's happened. Sorry, but I don't know what's happened. If I now, can you see?
Yes, now it's working.
Okay, perfect. Okay. Thank you very much, Alberto, to introduce me. I am Valentina Renarduzzi from Aalto University in Finland. And the paper that we are presenting today, it's a result of exploring 20 years of open source. You know that last year was the 20th anniversary of open source, and our idea was to derive some conclusion. And the title emphasizes this conclusion because it's how Cathedral embraced the Bazaar and how Bazaar became a cathedral. A little background of why we decided to do this research. You know that in 1997, Eric Raymond just opposed two ways of software development, the cathedral and the bazaar. And consequently, the cathedral was the way to develop software, especially for open source, because the software is developed in a closed group of developer teams, and it's only released in structural intervals. On the contrary, on the opposite, Bazaar, it's the way much more used with proprietary systems, since also because the development process is much more fast and visible and an interacting of all time. You know that proprietary have to reach the market and have the point of view of the business much more in concrete than for the open source community. What's changed? If you make a comparison when started to develop this approach, now what changed? Proprietary reassembled the open source software. This is one fact. And the open source became much more mature and adopted. You know, there were conducted a lot of research, a lot of European projects were developed, a lot of model approaches to measure the maturity of open source evaluation, adoption. Now the people, the customer and the end user trust much more in open source software than more or less 10 years ago and also more. And moreover, open source adopt many proprietary centralized development schema. What means that they merge together, that were a lot of things that come from proprietary that became usual application in open source software development. And so companies start to consider, this is the important things, start to consider open source as trustworthy compared with the proprietary one. Now the problem is not I trust. Now the problem is which is the best solution for my company. More years ago, the problem was open source. What does it mean? I don't know. I can trust. Now the problem is not the trustworthiness as well. And so, why the cathedral embraced the bazaar? This is a question that we try to, important question that we try to solve. First of all, pre-open source software industry habits similar to the industry itself. It is an important fact. Large enterprise in this year had very established way to elaborate the process. And rigorous inspection are used to improve the quality and the process models. Thanks to this one, open source development challenged this. And the power of the open source as stemmed from programmer contribution, not by managing controlling. And another important thing is that there are a lot of tools that can support voluntary cooperation. So open source in the last year helped to shape new development process. For example, one of the most important help was in the pull request mechanism, in the continuous integration, in the development delivery. And company apply the open source software, and not only apply, but contribute directly to the open source, became part of the community. And this is important because this means, and this proves the mature level that open source software achieved. Big closed source software big closed source players such as Microsoft, Google, Amazon now became the major open source software contributors. 10 years ago, we cannot see this one. We cannot declare this one for sure. And we have a complete transformation from the organizational perspective to an operational culture. And this is another important result that open source software bring inside the closed community. Unscrupulous motivates to embrace software, open source software, then goes above. It's another important thing. No longer see viable business around each product is pictured to become whitewash in the public, picture of becoming Linux and OSS lover. This is also the change in the culture and change in what they're feeling. And of course, some accidentally misused in GPL component is another important thing. Now, on the contrary, how the bazaar turned into cathedral. We have to weigh in the opposite sense, reverse. Many open source software projects we know that work well. What means? Then they can host the infrastructure needed by the project, they contribute in a big chunk, and they invite other others to join in. So this is a fact. Open source software work well. Of course, we can have a project that doesn't work well, but is not due to the fact that are open source, to the fact of other error, other mistake, other design problem that they have, but not just for the poor sake that they are open source. Wide influence on what gets into the main branch of the project and what does not. And now we have also big name in open source software community that come from the close. And many open source projects have started to lose their bazaar development project and became much more structured. Stakeholder needs include ensuring the sustainability of the project, as several stakeholders have significant business based on key open source software. Based on these, and I say point of view, two different point of view that we try to analyze and to conceptualize, what to look for the next, because it's not end the story, is not finish the story is carry on. Hybrid nature of the source software, a change in the value chain are the main big looking for the next. For the first, hybrid nature of open source, develop as a bazaar, evolve toward the cathedral as they grow, gain business impact, and need to be organized to support the business stakeholders inside. Community that come from business need to move to the opposite direction and adopt, in part, the Bazaar model to get contributors from the community. And the modern way to accepting contributors is not so longer through a monolithic project model, but need to be much more a distributed ecosystem marketplace. And finally, changing the value chain have had an impact on open source and will have in the future the impact in open source. To conclude, based on our results, we can say that open source software as realized is fundamentally use promises. Don't speak again about mature trustworthiness. We have in the same level of the balance with close. The fact is it was well designed, well developed, and well maintained, not just things about open or close, depend on the purpose of the company. Open source, so deep in software industry, they are next to inseparable. This is an important result. And the benefit of both worlds is something to seek from both small company as well as giant enterprises. Thank you very much for your help and if you have, for your attention, sorry, if you have any question.
So thank you, Valentina, for the interesting talk. So we have already a question.
Yeah.
So you argue that everything is converging towards a unified Bazaar model. What do you think? Bazidal, so something that is a merge between the two, basically.
Yes, it's merged because they try to identify the pros and cons of the both method and try to merge in one single approach. Now the problem is that we have to establish if they really take what it's positive from both and merge together, or there is some problem that we have to solve. But the problem is just that they unify, taken from the two approaches, and now there is one common direction line.
Okay, so we have another question. Is it possible to take all advantages without the trade-offs?
In my opinion, no, because it's an important thing that we have to take in consideration. But of course, this one depends also, in my opinion, by the goal of the company and by the purpose of the project itself.
Okay.
But this is my opinion.
I have another question here. So do you think it is possible for enterprise companies to turn their teams to full OSS contributors instead of developing in-company closed source solution?
Again, this one is an interesting question, but depends on the purpose of the company, because could be also nice, because in my opinion, if the developers are mainly contributors in open source, if the major goal of the company itself is closed, they can learn something very important. They can learn more. But depend on the purpose of the company. In my opinion, could be an interesting approach. But everything is related to the company purpose and to the management of the company itself.
Okay, so I think we are done with the questions now. So let's thank Valentina again for this interesting study.
Thank you very much for this opportunity. And sorry for the missed problem with the presenter, because my colleague had my problem had the healthy problem, and so my colleague had the healthy problem, so I have to reply her.
No problem.
Just to tell you. Okay.
So we can go ahead. Thank you again, and let's introduce the next.
Thank you very much. Bye.
Bye. Let's introduce the next paper, the development of data collectors in open source system for energy efficient assessment. So the presenter will be Daniel. So please go ahead.
Good day, everyone. Hope you're able to hear me, Professor. Are you able to hear me, Professor Alberto?
I can see the presentation now is perfect. So please go ahead.
Okay. So I am Daniel Atonge, and I'll be presenting the development of data collectors in open source systems for energy efficiency assessment. Okay. So for a brief introduction, I would like to briefly explain why any modeling energy consumption of running application is a crucial activity in today's system. So for that, when we talk about running applications, in this scenario, we are referring to active and passive user applications and processes running on their machine. And by this, we want to, when we say we want to, how crucial are these activities, we mean that if we are not able to measure energy efficiency of application, what are the bad results we are going to get? And we realize that instead of answering that question, if we can see the benefits of modeling energy consumption in running applications, we realize that this research will give correlations, will produce correlations and trend, which will serve other research areas such as user satisfaction or developer productivity. So modeling energy consumption of running applications in our everyday applications is very necessary, as it is a big part of our everyday lives. We use applications every day. So to the aim of modeling energy consumption of applications, researchers have come up with a number of methods, which I'll highlight three of them today, which the hardware-based approach, the software-based approach, and the model-based approach. So these methods present their advantages and their disadvantages in various aspects. Beginning with the hardware-based approach, for an advantage, the hardware-based approach gives us the most accurate energy consumption value, or let's say an estimate. So using hardware-based approaches, we get more precise value for how much energy a certain hardware device or a certain machine is consuming. But on the other side, for the disadvantages, these hardware-based tools used in measuring the energy consumptions, these are very costly equipment which cannot be afforded by everyone. Like if I'm a simple user and I want to measure how my applications or how my system is consuming energy, I will not be, it is not friendly to go and buy an expensive, acquire an expensive equipment for this goal. So another approach is the software-based approach. In the software-based approach, we are actually using software. We're using software to go and get valuable information from the operating system on how each user application is using the resources, maybe the percentage of processor usage, memory, and disk read and write. So if you can collect this data and you can effectively compute to get an energy consumption value. So that's the second approach. With this method, it is let's say it is user friendly, it's easy to use, and it is cheap. Everyone can afford it. But on the downside, it is the least precise of all the approaches. Yeah, that's it. And the last approach here is the model-based. So in the model-based approach, we are actually using, it's a mixture. It's a hybrid of a hardware-based and a software-based method, because we need an equipment to be able to calibrate our parameters to be used in the model. So and it is specific to a particular device. So using the model-based approach, we need to calibrate our model, our parameters using a hardware device. Then the software part is going to work. We pass it through our model and we get values for our energy consumption. So for pros, in this paper, we'll be presenting the Windows and Mac OS data collectors, which have been developed by our team. And the result of this paper were actually applications. So this, I want to state that these collectors, they are profilers. It means they are just there to profile and give us feedback on how our system is consuming energy. So that it, with that part said, okay. So we jump to the development of our data collector. It followed a typical software development lifecycle. And we had the various phases, I would say. So I'll just try to highlight some of them, like that is the analysis or requirement analysis phase, because we were developing this piece of software for users, for people to use maybe in the industry or for personal usage. And we needed to get the user requirements. What would the user want to do with our application, or which, let's give them the possibility to, let's make their application usable. At this stage, we're just going through simple functional and non-functional requirement analysis. And we had like such functional requirements, like to be able to report errors and to be able to also update automatically the application. It means when we release a new version, the application should automatically get updated on our end users' machines. And for the design, as you can see, we have an architecture to the right. And this was the architecture that we used in the entire development. That is, we had the back end, and we have a dashboard to show the statistics to users, and our collector lies in the two layers above. That is we have various collectors on Android, Mac, Windows, and Linux. Then we have their API. So they actually communicate on the same API to talk to the back end and to store data for processing. And that was the design phase, was just the architecture, and also making sure that our users, we are going to be able to implement the requirements which we enlightened at the beginning. So towards the implementation, at this step, we actually, since this has to deal with very low level, low level programming, meaning we needed to get operating system specific, specific components, like how much processor how much percentage of the processor is being used by a particular application. So that said, we used the native programming language presented by all the platforms. So that is for Mac OS, we used Swift, and for Windows, we used C#, and that limits a lot of overhead from accessing these components. And that was it about the implementation. But the part we have implemented so far, that's the Windows and the Mac collector. So for testing, we went through various testing to name we did the unit integration program and system testing. So that was at the end of that, we were able to test our application at a larger scale. It means we provided the application to students to be able to test them, to track their project, how their computer or their various processes are consuming energy. And we think that this will could give them good feedback up to as to how their maybe is to user satisfaction, and the developer will know he'll increase his productivity somehow, because he'll know that maybe if his computer is not that charged and he has maybe a very light software running, he'll know what to do, the trade-off. Either he shuts down the software first and he finishes the basic tasks, or he limits his time and he uses this very energy consuming application. So we actually had to integrate our system to the back end, because the back end is made for all such collectors. Presently in this application, we even have we presently have agents. It means we have GitHub agents and other agents, Trello agents, to be able to talk to the back end. So we had to integrate our collector to the back end using authenticated requests, and also understanding the endpoints. Where do you send the collected information to? So for authentication, once a user is logged into the app, he gets a token, and with upcoming requests, while communicating with the back end, he's going to use that token for further communication, and that was it. So that's all about the integration and implementation on different operating systems. So we actually have done it so far for the Mac and the Windows, but we are working on, presently working on the Linux, and that's Ubuntu in this case, and Android. So the general structure of the application and the objective is the same, but since we're on various operating systems, of course their implementation is going to vary from one operating system to the other. So we trying to highlight these small differences. It can be differences in the application structure, how the user interface, or things like that. So for the Windows collector, as you can see, we have such interfaces which the user is going to see. And these interfaces came about from the requirements. So in the requirements, we needed maybe the data collection, the user should be able to modify the data collection interval. So we had that implemented, and we have, like here, we have a box where you could enter how many minutes, because this process actually is also, it's a consuming process. I mean, it is energy loaded or energy consuming. So a user does not want to send data maybe every 1 second. It's going to maybe kill the processor somehow. So that flexibility and that modifiability was also given to the user. And also automatic updates and automatic login, things like that. So for the data which is being collected, as we can see, we need the application which is running, the name of the application, and other things that we stated that we needed. That's the IP, the MAC address, and energy-related metrics. Energy-related metrics here, as we can see, we have maybe the disk read and write bits, the memory read and write bits, input, output, read and write bits or percentage usage of the processor and things like that. And the current battery level. So we keep all of that, and we later on send the data to the back end for further processing. So for the Mac OS collector,
Daniel, you have 2 minutes to conclude, so please try to speed up a little bit.
Okay, so for the Mac OS collector, we have the following view. It's the same thing, but little changes in the user interface and how things are done at the low level. So I'm happy we're at the conclusion. So what are the limitations of our developed tool? So we can only we can only go as low as user processes. Any finer granularity of energy related, maybe the circuits, and it is unachievable. So that's where we can end, and we can only give values for these user applications which are running. And also using the software-based tool, we don't have a value in an energy metrics like watt. We have a value which is relative to other values. So it's not an energy value. We will just have a certain value which represents how much energy this application is it's using. So for rooms of improvement, we think that we could use for improvement, we could go towards the model view, means having a tool which will calibrate our specific hardware device for computation, because the energy metrics is based on a lot more than just user application. It's based on the screen brightness, is based on other small components. So okay, not talking about unit energy and software consumptions, I would like to conclude the presentation by leaving the listeners with something to think about. What if the applications that we are building as developers or in the enterprise, what if we build these applications with no aspect of energy minimization in them? So we just maybe use the worst data structures, we use all the worst stuff that we could possibly put in applications.
Thank you, Daniel.
Yeah, that's all.
Thank you, Daniel, for the presentation. This is a very interesting problem that you are dealing with. So are there any questions? I think we have just time for just a single question if you want. We have it. So what energy consumption metric do you collect? Are they the same or different in the different operating systems?
So the energy metrics that we collect, if you want me to state them, they are the percentage of process usage, memory usage, network, disks, and input/output. So they are the same across the different platforms. But the problem that we realize is how to access them. That's usually the main problem, because all systems have these dependencies. They have the process usage and things like that, but how do you access them? That's where the complication comes in. So yeah, the question is yes. The answer is yes. These metrics are the same across the platforms.
Okay, so thank you, Daniel. Thanks a lot for the presentation. And I think that we can conclude this first session here. So now we have half an hour for the lunch break. So I would like to invite all of you to come back at 2:15. The link is still the same, but you can still be connected. So we can start again in half an hour with another session about the tool and methodologies, but the second part. Okay, so thanks a lot and see you later then.